All right, problem number 44. First, I would do the quotient rule. So I could rewrite this as log base 9 of, and so when it's subtraction, it condenses down to a division problem. So this is going to be x over x minus 4, and this equals 1. Now it's time to rewrite this in exponential form. So I'm going to start with the base, and then everything else is going to switch sides. The 1 is going to come over here as the exponent, and the fraction is going to come to the other side, x over x minus 4. Now, of course, 9 to the 1 power is just 9, so I'm going to immediately erase this 1. So it's just a matter of solving this equation. So I would go ahead and multiply both sides by x minus 4. All right, to cancel out the denominator. So the x minus 4's cancel out. So now I have 9 times x minus 4, which is 9x minus 36, is equal to x. So I think I will subtract 9x from both sides. All right, just to avoid getting 0 over here. So I'll have negative 36 is equal to negative 8x. And then I would divide both sides by negative 8. All right, to cancel these out. This is going to be positive stuff. This is going to reduce down to... okay, both of these are divisible by 4. So this is going to be 9 over 2. And that is the final answer. Okay, take a look at problem number 45. First thing you want to do is the product rule. These will condense down to a single log using multiplication. So I'm going to do x times x plus 4. So that's going to be x squared plus 4x. And that will equal 1. So now it's time to change the form. So I'm going to have 5, and the 1 will come over here, and the x squared plus 4x will go over there. Of course, the 1 power is not changing anything. So that's just a 5. So let's go ahead and subtract 5 from both sides. So we will have 0 is equal to x squared plus 4x minus 5. So hopefully this is factorable. So this is going to be x and x. 5 can only factor as 1 times 5. And we're going to need a positive 5 and a negative 1. All right, now setting these factors equal to 0, so x minus 1 equals 0, x plus 5 equals 0. That's going to give us x equals 1 and x equals negative 5. Now we need to check for extraneous solutions. You can't take the log of a negative number. So you have to plug it back in. Don't just assume that because it's negative, it's automatically extraneous. You have to plug it back into the original problem and see if you get a negative then. Even if I plug it in right here, when I have this 4 kind of balancing things out, still, negative 5 plus 4 is negative 1, so that's no good. So of course it automatically fails here. Wait, you can't see all that. If I put in negative 5 right here, I have the log of a negative number. So then the negative 5 is extraneous. Got to throw that out. But 1 is fine. If I substitute in 1 in either position, that's going to be a positive result. So I'm only going to have one solution to problem number 45. X equals 1.